Google CEO Sundar Pichai recently spoke about the slowdown of AI development. And so the question has to be asked, are we witnessing the peak of artificial intelligence? Or is this just a temporary pause before the next wave of innovation? The past decade has witnessed an unprecedented surge in artificial intelligence development. From the advent of deep learning to the emergence of large language models, AI has transformed industries and has permeated in our daily life. Breakthroughs like AlphaGo's victory over human champions and GPT's natural language prowess have captivated the world. This rapid progress has fueled immense investment and public interest, with AI startups proliferating and tech giants pouring billions into research. However, now questions are being raised about the sustainability of this breakneck pace. Some experts suggest we may be approaching a plateau in AI capabilities. This video will explore where we currently are with AI development. I'll explain why there's concern over AI slowdown and consider what the future might hold for this transformative technology. In addition to Sundar at Google, several other prominent figures in the AI community have recently voiced concerns about a potential deceleration in the progress of AI development. Demis, Hassabis, CEO of Google's DeepMind, has said that while AI is still advancing, the rate of improvement in certain benchmarks has begun to level off. Similarly, Yoshua Bengio, a pioneer in deep learning, has cautioned that current approaches may be reaching their limits. Some researchers point to diminishing returns in model performance, despite exponential increases in computational power and data. Industry insiders have said that breakthroughs are becoming less frequent and more incremental. Meanwhile, critics argue that many recent AI achievements are variations on existing techniques rather than fundamental innovation. These expert opinions suggest that the field of AI may be entering a period of consolidation rather than a period of continued innovation and rapid expansion. One of the most significant challenges facing AI development is the scarcity of high-quality training data. As models grow larger and more sophisticated, they require increasingly vast amounts of diverse, annotated data to improve performance. There is discussion in the AI research community that we're approaching a data wall, where easily accessible, relevant data becomes exhausted. This is particularly acute in specialized domains or languages with limited digital footprints. Meanwhile, the cost and effort required to create or curate new datasets are rising, potentially slowing progress as AI companies continue to raise large funds to buy more data. I spoke about the thirst for funding in a recent video with regards to OpenAI, but it's not just the cost of data that is stifling AI progress. Privacy concerns and regulations like GDPR further complicate data collection efforts. Some companies are turning to synthetic data generation, artificial data that mimics real-world data, to address this issue. But questions remain about its effectiveness compared to real-world data. The data wall concept suggests that future AI advancements may require more novel approaches to data acquisition and use, or fundamental changes in how AI systems learn and generalize from limited information. The AI community has long relied on the strategy of scaling up models and datasets to achieve better performance. And this approach has given impressive results, with models like GPT-3 and Palm demonstrating remarkable capabilities. However, simply increasing model size may no longer provide substantial gains, as was the case before. The computational resources required for training and running these massive models are enormous, raising questions about economic and environmental sustainability. There is real concern that we're approaching the limits of what can be achieved through brute force scaling. The relationship between model size and performance improvement appears to be logarithmic, meaning each doubling of parameters yields diminishing returns. This trend is prompting a re-evaluation of current architectures and training paradigms. The focus is shifting towards more efficient model designs, specialized architectures for specific tasks, and novel training techniques that can extract more value from existing resources. But despite concerns about a slowdown, many AI researchers and industry leaders remain bullish about the field's future. They argue that apparent plateaus in development are often followed by unexpected breakthroughs. Optimists point to emerging areas like few-shot learning, multi-modal AI, and quantum machine learning as potential sources of future innovation. Few-shot learning, for example, is an innovative approach in artificial intelligence that allows models to learn new concepts or tasks from a very limited number of examples. This machine learning method allows AI systems to classify elements and make predictions based on their similarity using minimal training data. It's very likely that the current challenges will drive more fundamental research into the nature of intelligence and learning, leading to more robust and generalizable AI systems. Proponents of artificial general intelligence maintain that we're still in the early stages of AI development, with the most significant advances yet to come. Invariably though, I believe that current limitations are temporary obstacles that can only be overcome through persistent research and innovation. It's also likely that apparent slowdowns in certain areas are offset by rapid progress in others, such as AI's integration into various industries and its increasing real-world impact that we're all now starting to see. As the AI field grapples with potential slowdowns, the importance of innovation clearly becomes paramount. Significant advancements will require fundamental shifts in our approach to AI. One promising direction is the development of more energy-efficient AI systems, inspired by the human brain's remarkable computational efficiency. Neuromorphic computing, an innovative approach to computing that draws inspiration from the structure and function of the human brain, and analog AI are areas of active research that can lead to breakthroughs that will steer AI into the next phase of growth. Another focus is on creating AI systems with better reasoning capabilities and causal understanding, moving beyond pattern recognition to true comprehension. Think of it like the delta between memorization versus understanding from first principles, with the latter leading to better outcomes and more richer insights. Current hiatus in AI development can be likened to that of a marathon runner hitting a steep hill. While the pace may slow, it doesn't mean the race is over. Innovations in unsupervised and self-supervised learning could help address data scarcity issues. Interdisciplinary approaches, combining insights from neuroscience, psychology, and other fields of learning, may also bring new paradigms for AI development. Also, advancements in hardware like specialized AI chips and quantum computing can also unlock new possibilities. It's likely that the key to overcoming current limitations will lie in reimagining core AI concepts rather than incremental improvements to existing techniques. Thanks for watching. If you enjoy hearing about stories in tech and you want to support this channel, the best thing you can do is to like this video and subscribe. See you for the next one.